Hello and good day. My name is Santiago Garcia and I'm going to be talking about the advancements in energy production from nuclear fusion. Just a brief introduction of what we're going to be covering. First off, we're going to start with what nuclear fusion is and how it can be beneficial. Then we're going to talk about the history of nuclear fusion and the advancements in fusion research. Then we're going to talk about fusion today and potentially fusion tomorrow. So what is nuclear fusion? Basically, nuclear fusion is a reaction that occurs when two atoms are pressed together under immense heat and pressure, forming a heavier element and releasing energy. The energy output from fusion is 10 times more efficient than nuclear fission, which is the splitting of atoms. Fusion is a coming together of atoms, fission is a splitting. Effective fusion procedures have been challenging to develop on Earth because the required pressure and temperature cannot be replicated, such as you see in a star. These pressures and temperatures have only been observed on Earth in the explosions of thermonuclear weapons. However, scientists have since designed and built devices that can generate temperatures 10 times hotter than the sun. The technology exists, but it is still in its prototype stages. In fact, in theory, the amount of lithium metal found in standard laptop batteries could fully supply a household with power for 15 years using fusion. In other words, fusion is a nearly limitless source of energy. Here's just a quick picture showing what happens during fusion. Two atoms come together under immense heat and pressure, and they fuse, forming a larger atom and releasing energy in the process. Now, a brief history on nuclear fusion. The concept of fusion was first proposed in the 1920s by Sir Arthur Eddington. He proposed that the stars produce their energy by the fusion of hydrogen nuclei into helium nuclei. It was published in the Internal Constitution of the Stars in 1926. In 1934, Ernest Rutherford was studying the atom structure with his famous gold foil and alpha particle experiment. And during that experiment, he discovered that deuterium fused into helium. And this experiment showed that heavier hydrogen nuclei can react more easily with each other. By the 1950s, scientists worldwide began researching ways to develop an effective fusion process. At first, world powers like the US, the USSR, and the United Kingdoms kept their research highly confidential, as one of their main goals was to weaponize fusion and use it in military applications. Unfortunately, or fortunately, whichever way you want to look at it, very small amounts of the fuel used in fusion reactions would be heated to those high temperatures at any given time needed for a thermonuclear explosion. Those small amounts of this superheated fuel could not be enough to detonate the quantities of materials required to fuel a weapon. If the superheated plasma ever were to make contact with a larger, denser object, the temperature would immediately go down, causing the reaction to stop. And because of this, the popularized idea of weaponizing a fusion reactor or reaction is literally impossible. Just a quick background on how thermonuclear weapons work, is specifically talking about fission-based thermonuclears. They use the fission-based bomb fuel to produce enough heat and pressure within the bomb to activate its fuel, which then uses the energy from the fusion process to release in the form of an explosion. It uses some fusion in the process, but it's mainly fission. Pretty soon the scientists and governments were seeing that fusion could not be used in any military applications. They declassified their research and countries began working together, with the US and USSR cooperating closely. In 1950, two Soviet researchers designed the tokamak. It uses very strong magnetic fields to contain plasma at temperatures up to 10 times hotter than the sun. Then in 1951, the stellarator was invented. These two devices I'm going to go into in depth with them, and I'm going to talk more about them later on. But basically, the design of the stellarator was the dominant device used for fusion research in the 1950s. But then experimental procedures and research done on the tokamak design proved that it was more efficient and practical, and as of 2016, it remains the most successful candidate for an efficient and practical fusion reactor. Fast forward to 1973. European countries came together and began to design the JET, or the Joint European Torus, 4 years later, the project was approved and it was completed in 1983. In 1997, the JET set the current world record for most fusion output. It used a fuel composed of half deuterium and half tritium, two different hydrogen isotopes that can easily react with one another to fuse and release large amounts of energy. Then in November of 1985, the Geneva Superpower Summit at the Geneva Superpower Summit, with General Secretary Gorbachev of the former Soviet Union proposed the idea to US President Ronald Reagan to create a worldwide collaborative project with the intent to develop clean fusion energy for peaceful uses. This event brought the creation of ITER, the International Thermonuclear Experimental Reactor. A year later, in 1986, it was agreed that the European Union, the United States, the Soviet Union, and Japan would form the backbone of the ITER and design the International Fusion Research Facility. The concept work began in 1988 and the design was finally approved in 2001. Members all agreed on building the project at a site near Aix-en-Provence, in the south of France. So far, the ITER tokamak remains the world's most advanced and sophisticated magnetic containment fusion experiment in the world, with over 2,000 people working at the site in France. Now, what exactly is a tokamak? Well, a tokamak uses very strong magnetic fields to contain the plasma at very high temperatures, up to 10 times hotter than the sun. At temperatures this high, the atoms are completely ionized, turning them into plasma. The tokamak's confinement area is in a toroid shape, in other words, resembling a donut. It uses the magnetic force to keep the plasma isolated from the solid confinements of the reactor, preventing the heat dissipation and its destruction. In other words, if plasma this hot were to come into contact with the physical confinements of the reactor, it would destroy the tokamak, or anything in general. And this is just a very basic sketch of what a tokamak looks like. It's got the magnetic coils going all around it in different directions, directing the plasma current through the middle, isolating it without actually touching the physical barriers. Now, a stellarator is very similar to tokamak in the sense that they both contain plasma using ring-shaped magnetic fields. The only difference is that the fields that the tokamaks create, they use part of their fields they create is using an electric current flowing in the plasma, while the stellarators build their magnetic fields exclusively from external coils, as you can see in the bottom picture. The picture on the top is a rendering of a tokamak, and on the bottom it's the stellarator. You can see that it's got these weird things sticking out of it, and it also kind of twists and turns. Now, what does fusion hold for the future? Unfortunately, now the only fuels being used for fusion research are the half deuterium, half tritium fuel that I was talking about earlier. This kind of limits the fusion research. Who knows what other potentially more efficient fuels are out there? But yes, fusion can potentially be clean and nearly limitless source of energy. What do I mean by clean? I mean that it produces basically no radioactive or toxic residue, and because of this, it can help reduce carbon dioxide emissions exponentially. Once an effective way to produce fusion energy is produced and mainstreamed, our need for fossil fuels can be discarded in most settings. Projects such as the ITER and tokamak research in China are getting close to find a solution for effective fusion energy. They speculate that by 2029 we will have an effective fusion reactor up and running and producing energy. It can become profitable in the near future, in other words. Well, this has been advancements in energy production from nuclear fusion. As I said before, it is still in its very preliminary stages, but it's slowly moving on, it's slowly advancing, and hopefully one day we can be prepared for the future and have the gift of this clean and nearly limitless source of energy. Once again, my name is Santiago Garcia. Have a good day.